All right, so we are JediBall. And Kangho and I, this is Toshi, I'm John. Kangho and I we also took we also were taking brain-computer interface class at the Media Lab, where we learned to use these used headsets. This is a consumer-grade EEG headset, so it's reading electrical signals from my head right now. So that's what we're using to drive our game.
All right. So what we're using from the EEG headset is that first we're using the readings for your alpha and beta waves. So alpha waves are stronger when your brain is more relaxed, and beta waves are stronger when you are more focused. And we're also using the accelerometer on the headset to check for your direction. And how it works in this game is that you're either using your alpha or beta waves to control the speed of your ball. And for the direction, you're going to have to tilt your head left and right. But we added a twist to it here where you use your brain waves to influence the magnitude of the turning, and your head tilt will only influence the direction. So, John, you want to demo?
Let's give it a go.
All right. Let's start with just tilting. Okay, and yeah, we managed to get it to just be able to reset at the press of a button.
Try it again. So what you might notice is the more I'm concentrating, you'll see the values for my alpha and beta waves fluctuate. And when I get distracted, they'll change too. So it's actually really hard to control when you're in a room full of people, not surprisingly, because a lot of it's based on how hard you're focused. So.
Yeah, and how we switch between the waves is actually we track your blink. So with one blink, you just switch to the other one. But we have some problem with this because it's tracking multiple frames, so the blink could last for multiple frames and it could jump back and forth. We're still trying to figure that one out, but yeah, the gameplay is generally done.
Tosh, want to say anything else?
Okay. So this is the first. I have never used the Unity, so this is a beginner course. I learned something. For example, there is a stardust here, you can see, and I wanted to learn how to put such kind of particles, and you can see the actions. If we hit the obstacles, there is some particles appeared, and also another particle appeared at when we hit the pin. So there is a script to check which which collider hit to which collider, and you can see the spotlight are turning around, and I wanted to do this with a foggy spotlight to see some ray, but I found that this is not so easy. So. This is the current challenge I want to learn. And I use the physical material for each object. So the floor is almost icy, so very low friction. And the obstacle has some bounciness at 0.7 or 0.5. And actually, I started to learn how to model the message for the pin in a Unity, but without using like a Blender modeling. So that we can use procedural mesh scripting, and I tried, and I couldn't finish this yet. So I'm using just a simple cylinder as a pin. But I found that for each this cylinder, standard primitive still has some problem, because the cylinder collider is basically the capsule collider. So the original collider, if we use, if once we hit, it is very easy to knock out. And so we needed to change the collider from capsule collider to mesh collider. Okay, and another thing, so you can see that this is a main camera which is following the ball, and once this ball go to some threshold beyond that line, then the goal camera appeared like that. And actually I had another challenge to put this goal camera has no border frames, so it may be not so easier to distinguish which one is the main camera and the sub camera. But I try to use texture renderer to put the camera onto the canvas, but I couldn't figure out how to do that.
Yeah. Any questions?
You should send this to Disney. I imagine like a pod racing game with its controls.
Yeah. Since Disney owns the Star Wars rights now, I'm afraid that they'd sue us for copyright infringement. But
sold it.
right. But yeah. No. But it would be fun to market it.
Okay, so I'm kind of curious of how the alpha and beta waves influence the way the controls work, because how does that combine with the tilting?
Right.
All right. So how it works is that we are taking these exact values that you see, and we're multiplying it into with some multipliers to apply a force on the ball. So when in tilt-only mode, what happens is your alpha and beta waves, they only affect the forward motion of the ball. So how fast the ball is moving forward. And when it's in tilt and tilt plus brain mode, your tilting only influences the direction, and the magnitude is determined by your alpha or beta waves as well.
So if you're distracted and tilting, it doesn't matter.
Yeah.
It only kind of matters. But if you're really focused and you tilt, it's really strong effect.
Yeah. But there is a certain threshold, so if yeah, so the wave in use, if it's lower than 0.2, you won't be able to trigger the turning at all. Yeah. I saw a few other questions. Oh, yes. Oh, that's just for the electrodes. So there are 4 electrodes on the headband, and they have to be in contact in order to get a proper reading. So like what happens is back connection, basically you're only getting 1 electrode that is really contacting your forehead. And OK connection, you have like 2 to 3, and good is 4. Yeah.
There's a sensor here and then 2 back here. 2 here and 2 here.
Sorry. Now we should call.